In this task, we have the series connection of a resistor and an inductor, and a sinusoidal current flows through this series connection. And now we are asked to find the total voltage drop at the two elements, and we are asked to find the phase shift between this sinusoidal current and the sinusoidal voltage drop. Let's draw our network. So we have this series connection and we know that a sinusoidal current flows here. And we are looking for the total voltage drop. And therefore we know it will be the sum of the voltage at the resistor and the voltage at the inductor. And we can calculate them both with Ohm's law. Okay, let's draw a phasor diagram to get an overview what happens there. We have a current that flows through both elements. And we know that voltage and current are in phase at a resistor. And therefore we can draw the voltage like this. And we know that we have a phase shift of 90 degrees between voltage and current at an inductor, and the voltage leads, and therefore it looks like this in the phasor diagram. And the sum of the two voltages is our total voltage. And we are asked to find this total voltage, and we are asked for the absolute value of this voltage. Okay, let's have a look. This total voltage is the sum of the single voltages, and therefore it can be expressed like this. And this here is the correct equation for the complex voltage. So this complex number we get also includes the correct phase angle. But we are only asked for the absolute value of the voltage, and therefore we use our friend Pythagoras and can write it like this. With the given number values, it's like this, and the result will be 301.26 volts. And now we are asked for the phase angle between the current and the voltage. So this here. We know that voltage and current are connected by Ohm's law. And therefore you see that the phase angle is defined by the impedance. And let's draw a phasor diagram for the impedance. So the resistance is a real part, the inductance is the imaginary part, and therefore this here is our impedance. And we can find the same phase angle here. We know that the tangents phi is the opposite leg divided by the adjacent leg, and therefore we can calculate it like this. And with the given number values it looks like this, and if we type this in a calculator we get to a phase shift of 38.73 degrees.